everyone. I'm Annie Rogers, and on behalf of the ADDitude team, I would like to welcome you to part one in a two-part series on circadian rhythm with a presentation titled How Your Circadian Rhythm Shapes Energy, Focus, Productivity, and Cognitive Functioning. Leading today's presentation is Dr. Jamie Zeitzer. He is a professor of psychiatry and behavioral sciences and co-chair of the Center for Sleep and Circadian Sciences at Stanford University. An internationally recognized authority in sleep and circadian science, he has authored more than 150 peer-reviewed publications, including papers for PNAS, JAMA, Sleep, and Nature Family journals. His work integrates neurobiology, light exposure, wearables, and clinical trials to advance sleep health across the lifespan, alongside a long-standing commitment to interdisciplinary mentorship and public engagement. In a 2025 survey of more than 2,000 ADDitude readers, 2/3 of you said you've experienced an adverse event like a car accident or job loss due to poor sleep quality. Half of you said you wake up at least one time a night, and 1/3 said you struggle to get out of bed. I don't need to tell you that chronic sleep problems are bad overall, and they can exacerbate ADHD symptoms like poor focus, concentration, and productivity. When our sleep falters, energy levels plummet, attention becomes fleeting, performance suffers. If you fall into a nightly hole of revenge bedtime procrastination and your circadian rhythm or body clock are working against you, you're in the right place. Today, we will learn how ADHD pushes circadian rhythm out of whack and what you can do to right the ship. We would like to begin today's webinar by asking a quick poll question of our live audience. If school, work, and other obligations disappeared, what time do you think your body would naturally fall asleep? And likewise, what time would your body naturally, quote unquote, wake up if left to its own devices? Please select the answers that most closely match your experiences. And you can always use the comment box under the video to tell us more. And we'll circle back and let you know what the averages were for today's audience before we kick off our Q&A. While you do that, I will mention that answers to common webinar questions about slides, transcripts, and certificates of attendance can be found by clicking the FAQ tab of your webinar screen. I'll also mention that ADDitude Magazine subscribers received our brand new spring issue last week, and it takes a deep dive into masking, burnout, and the chronic pain that often accompany autism. We also report on ADDitude's cost of treatment survey, which reveals what real families are paying for ADHD care today. And inside, you'll find 26 questions to reveal your ideal career match. If you want to read the full issue, subscribe to ADDitude Magazine today by visiting additudemag.com/subscribe, or you can click the Subscribe Now tab on your screen. And finally, the sponsor for today's webinar is Inflow. With ADHD, productivity isn't just about time management. It's also about energy, knowing when you can focus, when you need rest, and how your natural rhythms shape your day. Inflow gets it. Our science-backed, doctor-designed program helps you recognize what works best for you and build daily routines that work with your brain, not against it. Click the link on your screen to take the free ADHD traits quiz to get started. ADDitude thanks our sponsors for supporting these webinars. Sponsorship has no influence on speaker selection or webinar content. Okay, without any further ado, I'm so pleased to welcome Dr. Jamie Zeitzer. Dr. Zeitzer, thank you so much for joining us today and for leading this really compelling discussion.
Thank you so much for having me. I'm excited to be here. So circadian rhythms. It's something that I hold near and dear to my heart. I've been studying them for about 30 years. But what I'd like to do is start off by defining what is a circadian rhythm. And not everyone knows. When I first started this journey, I had no idea what one was. I had never heard of it. But a circadian rhythm, kind of defined, is a near 24-hour oscillation. That's not exactly 24 hours. It's around 24 hours and 12 minutes in humans on average. It can be synchronized to a 24-hour day. It's endogenous to an organism. So it's basically within the organism. It's not created from out. And it's ubiquitous in nature. Every living organism that has been studied on the planet Earth has been shown to have a 24-hour clock. And this includes animals, plants, single-celled organisms, organisms without nuclei, organisms that live less than 24 hours, all have circadian clocks. So there's something incredibly important if evolution makes this thing stick around for so long. So the question is, what is it? What is so important about a circadian clock? Well, really, there are kind of two things that a circadian clock does that are very important. One is that it predicts changes in environment. And what that means basically is that instead of responding to changes in the environment, it can predict when they're going to occur. So it can anticipate when you're going to wake up and get your body ready for waking up. It can anticipate when you're going to eat and gets your body ready for when you're going to eat. So again, most physiology is very responsive. You eat food and then you respond to it by digesting food. This is basically in anticipation of that. And there's lots of evolutionary advantages if you're able to anticipate when things are going to happen as opposed to just responding to it. So if you can imagine if you are say a rabbit and you're outside and you want to get into the burrow before it gets too bright out, well, it's better to know when the sun is going to rise than responding to when the sun is actually coming up. The other thing that it does is that it can coordinate clocks in various tissues. So there's a central circadian clock, and I'll show you where this is. And this can basically help clocks in peripheral tissues remain synchronized to each other. So let me give you an example of something that we all do every day and that the circadian clock is fundamentally involved in. And this is waking up, right? Waking up is actually, from a physiological perspective, an incredibly difficult thing to do. It takes a lot of energy. And if you want to experience what it's like if you don't have a good circadian clock, if you ever wake up in the middle of the night, it's 2 o'clock in the morning, you wake up, you have to use the toilet, you get up, and then you feel a little lightheaded. Then you grab the side of the bed, and after a couple of seconds, you're okay. Well, that's because your body was not ready to get up. Now, again, it responds to getting up, but it wasn't ready. Because what do you need to do this? Well, basically, if you're lying flat, you're lying supine on the bed, all of a sudden, you're standing up. Well, when you're lying flat, gravity's acting equally, and then when you stand up, all that blood's going to rush out of your head. And that's feeling lightheaded. So what do you need to do? Well, you need to have glucose released from the liver. You need to have epinephrine released from the adrenal glands and the kidney. You need to have your heart rate increase, and all this stuff has to happen in anticipation of wake up. And when that happens, then when you wake up normally in the morning, you don't feel lightheaded when you get out of bed. So this is the kind of thing that it can do, is that it can kind of anticipate what is supposed to happen as opposed to responding to what is actually going on. So where does it come from? Well, the central circadian clock is located in the SCN, or the suprachiasmatic nucleus. It's a really small group of neurons in the brain. There's around 10,000 neurons in each side. They're highly interconnected. They're located just above something called the optic chiasm, which is where the fibers from the eyes cross before they go into the thalamus of the brain. And if you take out the circadian clock, the SCN, in mammals, you lose circadian rhythms. So this is where they originate from. This is where they come from. And it's really small. It's around the same size in a human as it is in a mouse. So it's very tiny. And like I said, this is the central circadian clock. Now, you have clocks all over your body. There are clocks in your liver, there are clocks in your gut, there are clocks in your muscles, clocks in your immune cells, and all of these clocks can synchronize to local signal. So clocks in the muscles are going to respond to when you normally exercise, and they can anticipate that kind of exercise timing. Clocks in your gut are going to respond to when you eat. The central circadian clock keeps these all aligned. And so what it does is basically similar to what a conductor does in an orchestra. So if you're sitting in an orchestra and you're sitting in the violin section, or you're sitting in the horn section, or the harp section, or the cello section, the instruments sound fine. You're sitting with the flutes sound great. If you're sitting in the audience and the conductor is weak, it's cacophonous. It's just a little off. It's not that they can't play, it's just that they're not quite aligned. And that is basically what is happening with the SCN, is the SCN is optimizing the alignment among all of these different kinds of organ systems so that they are they basically have the best function that they can have. Okay? If you get rid of the SCN, the animal doesn't die, right? If you cut out an SCN in a mouse, the animal does not die. But the animal is definitely less robust. They live less long, they get more diseases, more problems. So SCN is definitely not necessary, but it is very important for optimizing your health. Now, the thing that the SCN does that we can observe the most is how it works with sleep. When you take a look at the circadian clock, it really is adjusting not how much sleep you're getting, but really when sleep is occurring and how consolidated sleep is. And it does adjust how much REM sleep that you have. So this is the thing to keep in mind as we talk about kind of sleep and circadian rhythms here. When you think about sleep and ADHD, there are various kinds of phenotypes that are really common in individuals who have ADHD. One is that people have a late sleep onset. Now, late sleep onset in and of itself is not that problematic, right? If you just go to sleep late, but you still sleep around 8 hours, that's for the most part fine. There are some issues that we can talk about that are associated with that, but biologically speaking, that's pretty much okay. The problem is that if you have to get up early in the morning for work or for school, that curtails sleep, and then you have insufficient sleep. And then that becomes problematic because then you have chronic sleep deprivation. A second common phenotype is having an erratic sleep schedule, especially in sleep onset. This is where some nights you go to sleep at 11, some nights you go to sleep at 2, sometimes you go to sleep at 4, sometimes you go to sleep at midnight. It's all over the map. This kind of erratic sleep schedule, it can really hurt the circadian clock. And then in around 44% or so, according to one survey, and again, there's all sorts of numbers out there, people with ADHD have insomnia. Some of this is related to the circadian clock, which I'll show you. Some of it's related to medication. Some of it's related to the pathophysiology of the disorder. So how is this related to the circadian clock? How is sleep and ADHD related to this clock? So one of the critical things that sleep does, that circadian clock does with sleep, is that it allows for consolidation of sleep. It basically allows you to have 16 hours awake and 8 hours of sleep. And this is a stable thing. This is actually something which is naturally occurring. If I take people, bring them into the lab, and you basically you kind of mess with their sense of time of day. There's no windows. They don't know what time it is. And you just allow them to self-select their sleep-wake cycle, and they're not sleep deprived. They'll stay awake for around 16 hours and sleep for around 8 hours. This is just what your brain is naturally programmed to do. And this is, by the way, even if you've got nothing to do, even if you're super bored, this is what you do. You don't have to be stimulated into 16 hours of wake. This is something which is your brain is kind of pre-programmed to do. And actually, amongst mammals, this is a fairly unusual kind of thing. So how do you get to this 16-8 structure? Well, you basically have two different phenomena going on. One is the circadian clock, and the other is the homeostat. And the homeostat is basically something that measures how long you've been awake and how long you've been asleep. But the idea is that the longer you've been awake, the more tired you get, and the more you sleep, the less tired you get. It's pretty straightforward. So one could think of it that you have some magical threshold for sleep, and then once you have a certain drive for sleep that crosses this threshold, you'll get tired and want to go to sleep. And so what happens is that you have a homeostatic drive that basically kind of looks like this, which is that over the course of the day, your sleep homeostat, your drive for sleep increases. And so you can see fairly early on, if it was just that, you'd go to sleep. And without a circadian clock, this is kind of what you see. You kind of see where you would expect more of like 4 hours of sleep, followed by 4 hours awake, followed by 2 hours of sleep, followed by 4 hours awake, followed by 2 hours of sleep. That's the kind of pattern that you would expect to see in people. But what happens is that the circadian clock actually kicks in a wake drive and has a very strong wake drive that increases in strength in the latter half of the day. And this keeps this kind of sleep need or this keeps this homeostatic threshold lower and basically prevents you from actually going to sleep until around 16 hours. And so actually your maximum wake drive is in the hours before your normal bedtime. And you can experience this if you travel from, for example, if you're traveling from California to New York, you normally go to sleep at 11, you try to go to sleep at 11 in New York on your first night there, and you can't. Why? Well, because in your brain, it's still 8 o'clock in the evening. And when it's 8 o'clock in the evening in your brain, your circadian system is driving really hard to keep you awake, making it very difficult to fall asleep at that point. So this is kind of consolidation, how consolidation works. You have a similar kind of thing for sleep, which is basically the longer you stay asleep, the less drive for sleep that you have. And at some point, you're going to reach this threshold for wake. And then you have this kind of circadian sleep drive that kicks in the latter half of your sleep episode, keeping you asleep for the full 8 hours. And if any of you have spent a full night awake and kind of pulled an all-nighter, hopefully not recently, but if you've pulled an all-nighter, you feel that second wind in the morning. So even though you've been awake for even longer, you feel more awake. Why? Well, 'cause actually what's happening there is that after around 22 hours of wakefulness, you're really dragging because you've been up for 22 hours and circadian sleep drive is really strong. But after around 24 hours of wake, which is the normal time you would wake up, you're still up for now even longer, but the circadian sleep drive is no longer there. And so that kind of drive disappears, and so you're actually more awake. And when you take a look at this in a lab and actually can quantitate this stuff, you actually see that people are more tired after 22 hours of wake than they are after 40 hours of wake, which is a little counterintuitive, but that's kind of because after 40 hours of wake, you've got a strong sleep drive. So this is kind of how this kind of 16-8 pattern evolves. Now, I should mention that there are two other patterns that are possible and that are stable. One is having a siesta, and that's basically you have a slightly shorter night's sleep, so around 6 or 7 hours a night's sleep, and then a midday nap. And the siesta is possible because basically that midday nap is basically creeping in right when you've built up enough homeostatic pressure and the circadian drive for wake isn't too strong. And so you can kind of get that in there. And the other is something called split night, which has really been only observed, or at least reported on, in Northern Europe during the Middle Ages. And this is where there's a 12-hour night, basically, and you can't sleep for 12 hours, yet lighting was very expensive and it was cold, especially in the wintertime. And so basically people would go to sleep in the winter around sundown, sleep for around 4 hours, then they'd have several hours awake, 3-4 hours awake, and then go back to sleep for another 4 hours. So again, that's also a stable thing. But the real question is, what does this have to do with ADHD? Well, one of the problems is that in many individuals who have ADHD, they can have an erratic schedule. They stay awake late, they have insomnia, which makes it difficult to fall asleep on time. And when you have that, you're generally not just sitting in bed in the dark. What's happening is that when you're sitting in bed, you're doing something, or if you get out of bed, you're doing something, and that requires light. And light is the main way that this internal clock remains synchronized with the outside world. And when you're getting exposed to light, you're not only changing the time of the clock, but you're also changing the amplitude of the clock, or how strong the clock is. So when you have erratic light schedules, which are coupled with erratic sleep schedules, you get a weaker circadian clock. When you get a weaker circadian clock, that makes it more difficult to stay awake during the day and harder to sleep at night. These are all feeding into each other and causes this really bad kind of doom loop where basically it's harder to stay awake during the day, so you nap during the day. And then you nap during the day and it's harder to sleep at night, and you've already slept some, so then you don't sleep as well at night. And then you're tired during the day, and then you sleep again during the day. And again, you get this really nasty loop that basically weakens the circadian clock considerably. And when you get this weakened circadian clock, then during the daytime when you're up, you're going to be sleepier during the daytime. You're going to be more fatigued during the daytime. You're going to have increased emotional lability during the daytime. And frankly, if you're looking long-term, you're also going to be much more susceptible for a variety of problems. In the short term, you really be looking at, a greater susceptibility to infectious disease. And in the long term, you're talking about, instead of just mood problems, you would actually have greater risk of developing depression. So again, you've got this really nasty loop that can happen in individuals with ADHD, especially when you've got this kind of erratic schedule. So what can you do about it? So I should tell you, I don't like platitudes. I find that they're in generally not very helpful for people. So I could tell you something like, yeah, be very regular and get 8 hours of sleep per night, which is great. I mean, it's not wrong, but if you could do it, you'd probably be already doing it. All right, if you can't do that, what can you do? Well, can you try to increase regularity? Try to get around 7 hours or more of sleep per night. can you do that for, at least a few nights out of the week, or at least be conscientious of what you're doing? That's something that I think some people could do, and other people, it's like, well, my life doesn't do that, so I can't do it. Another thing that you can do is you can just actually, especially if you have eastward-facing windows, just sleep with the window shades open. Because what will happen is that when the sun comes in, the sun is really quite strong. If you're looking at, at sun coming through a window, depending on where you are, you're going to get several hundred up to a couple of thousand lux of light coming in through your window. That will actually pass through your eyelids, even though they're closed. Around 10% of light gets in. So it can actually go into your brain and help synchronize your circadian clock, even if you're asleep. So even if you're asleep and have an erratic schedule, having that kind of sunlight exposure early in the morning can help. Or alternatively, you can get a sunrise simulator. There's lots of them out there. I don't have a recommendation for any particular one, but that is something else that you can do that can also help you regularize your circadian clock and help increase the amplitude. So really you have to think about, what is preventing you from having this regular schedule. And again, there's work-life demands. And to me, this is some of the most immutable stuff. Again, you can try, but it's often very difficult to kind of balance that out and kind of prioritize sleep. And then you get the problem is that if you have a weak circadian clock, you're not feeling tired at the same time every day. And so it's really hard to have a regular sleep time. So you don't want to go to sleep if you're not tired, because that'll kind of engender insomnia symptoms. And so that's not great. But the one that is really, the most changeable is the issue of entertainment. Is kind of, what are you doing late at night? Now, I'm not saying you shouldn't have any entertainment at night. Absolutely not. I'm just saying you should be aware of what you're doing. And it kind of gets into this issue of devices at night. And so there are a couple of things that these devices are doing. And when I'm talking about devices, I'm talking about electronic devices, computers, laptops, phones, tablets, televisions, things like that. And just because you watch something on your phone doesn't make it any better or any worse. However, there's two things that are going on. One is that it's giving you light at night when you shouldn't be getting light. The other is that it's displacing sleep. So I have to say, these things are kind of designed to keep you occupied and not get sleep. So what is the issue with light at night? Well, so light at night comes down to this, which is that your visual sensitivity, so your conscious perception of light, peaks in the green region, right? It's around 550 nanometers. So basically, when you're seeing the world around you, if you're given the same number of photons of green and red, the green will appear brighter. So you're more sensitive to green than you are to other wavelengths of light, including blue. Typical LED screens and LCD screens have a blue peak in them. So there's a lot of blue light in them that you're not consciously aware of. Now, this is problematic because the circadian clock, at least over longer time scales, is very sensitive to blue light. It's more sensitive to blue light than to other wavelengths. And so what happens is that, okay, well, you're being exposed to light at these times. You don't realize how bright it is because perceptually it doesn't seem that bright, but the circadian system thinks, it's super bright. What are we going to do about this? So that has led to this conception that all you need to do is filter the blue light. Well, there's a problem with that. And this is a clip from Reed Hastings, which I'll just read this. He is the CEO of Netflix. And this is several years ago, actually almost 10 years ago, during a corporate earnings call. So this is actually, if you want to look it up, this is on YouTube. So not stealing anything here. And he goes, think about it. When you watch a show from Netflix and you get addicted to it, you stay up late at night. You're really we're competing with sleep. Needless to say, people in my field were a bit horrified by this. And Netflix being Netflix, several hours later, they tweeted out, "Sleep is my greatest enemy." So these devices are designed to keep you awake. So is it the light that is really keeping you awake? Not so much. One of the things that is happening is that the amount of light that you're actually being exposed to isn't that bright. It seems bright because you've got this green and you've got brightness in the screen and then a big dark space around it. And so people think, this is super bright and I'm not going to be able to sleep. So in the lab, you can show that this is true. But in the lab, what you do is you keep someone in dim or darkness, so very dim light or darkness, for hours prior to exposure. When you put somebody in normal lighting, normal room lighting, and then give them exposure to a device like this, their alertness really doesn't change that much. So the light coming from your screen at night that you're getting, if you go outside at all or in bright room light at all during the daytime, is really inconsequential to keeping you awake. Now, it can definitely keep you awake if you wake up in the middle of the night. So if you've fallen asleep and you're asleep for several hours, you're in darkness, and then you wake up, and then you put on a device, that device can then wake you up. That amount of light can wake you up. But really what the device is doing is that these things are optimized to keep your eyes on the screen. That's what the apps do. Basically, the more you use it, the more money they can charge, the more money they make. It's designed, honestly, to displace sleep. And so you should really be aware of that. Secondly, it can also increase positive or negative emotion, both of which can make it more difficult to fall asleep. So I can say, if you check your email right before you go to bed and it stresses you out, that's probably not such a good thing to do. Try to avoid that if you can. Basically, I don't check emails at night, and really not much on the weekends, because generally the only emails I'm getting then are things like, hey, Dr. Zeitzer, here's this really stressful thing you can't do anything about until tomorrow. Have a good night. Really frustrating. So I basically stop checking the emails. So that way I can just deal with these kinds of things in the morning instead of having it completely disruptive to sleep. So, what can you do? Mitigation strategies. Well, again, ideal is remove electronics from the bedroom. If you live in a studio apartment, that's obviously not happening. Many people don't want to remove their electronics from the bedrooms. They like it. They like playing on their phone. It relaxes them prior to going to sleep. You don't have to, but it is helpful. An imperfect one, but that one that can help, is get afternoon light, or at least bright indoor light. So either go outside for a walk, which is always great. Again, it's cold in lots of areas of the country right now, so it's a little more difficult to do. But even if you sit by a window, you get a lot more light. Just to give you some numbers to understand is, standard kind of bedroom lighting is around 75 lux or so, 75 to 100 lux. A well-lit doctor's office or a bathroom or a kitchen might get up to around 500 lux. Sitting by a window, you're getting more than 1,000. You go outside and it's cloudy, it's around 10,000. A bright summer day, it's 50 to 100,000. So again, you're talking about orders of magnitude more light outside. So going outside during the afternoon changes how your brain is responding to light in the evening. And so it's really great to do that. And then again, something else you can do is with the app is, just be aware of how it's impacting your behavior. If it's something that you need to kind of wind down at the end of the day, I get that. That's something that you can do. Just don't pick something that is going to be so engaging that it's going to keep you up even longer. Can it be a little more boring if it's got to be something there to help you kind of wind down? So again, these are some things that you can kind of do to help out. And it's really the key thing is just being aware of how it's impacting you. How else do circadian rhythms impact sleep? Well, one of the things that can happen is that this kind of chronic disruption of circadian rhythms can lead to insomnia. And the insomnia is often in this kind of disruption is that you're trying to go to sleep, but your brain is not ready to go to sleep. And then you become worried, like, why am I not falling asleep? I'm tired, I think. Am I tired? Should I be going to sleep? What's going on? And then your brain starts the cycle and keeps you awake. And then it can lead to insomnia, which, as I mentioned, around 44% of individuals with ADHD have this. When you actually look at the brain waves, the EEG during sleep in individuals with ADHD, and you compare it to neurotypical, it's not very different. So we don't think that the insomnia is inherently different in individuals with ADHD, but it's definitely more prevalent. And again, this can be due to circadian clock. It can be to other reasons in terms of timing of medications. It can be related to the actual pathophysiology of ADHD and some of the symptoms that it generates that may make it more conducive to staying awake later and getting involved in activities that are going to kind of displace sleep. So all of these things are absolutely so. But when we're focusing in on kind of the circadian aspect, this can independently lead to having insomnia. When we talk about insomnia, it's important to understand what is and what is not insomnia. And so this is kind of the canonical definition of insomnia, difficulty initiating, maintaining, or reinitiating sleep. It has to happen 3 times per week for at least 3 months. And I have to say those are kind of arbitrary numbers. You have to have an adequate opportunity to sleep, and it's not due to something else. And one of the critical things it has to have clinically significant daytime distress or impairment. So just not getting enough sleep is not insomnia. If you're not getting enough sleep, that's inadequate sleep. It's not good, but it's not insomnia. Also, what I want you to notice is that besides this kind of slightly arbitrary 3 times per week for 3 months, there are no numbers here. If it takes you 30 minutes to fall asleep and it doesn't bother you, that's not insomnia. That's just taking 30 minutes to fall asleep. Is that longer than it should? Well, it's longer than normal, but again, it's in and of itself not pathophysiological. If it takes you 5 minutes to fall asleep, which is, by the way, very short, but it bothers you, that's insomnia, even though it's on the very short end of how long it should take you to fall asleep. So again, thinking about insomnia, it's important to keep this kind of definition in mind. And when you take a look at it, I always go off this Anna Karenina principle, and my apologies to Leo Tolstoy for kind of bastardizing his work here. But basically, this idea is that all good sleep is similar, but each person's sleep is bad in its own way. And what that means is that if you look at a good sleeper, I don't need to do a recording to tell you what their sleep looks like, because good sleepers' sleep all looks the same. In bad sleepers, there are hundreds, if not thousands, of causes and phenotypes of what bad sleep looks like. It is very rare. And in fact, if you talk to people who have bad sleep, so if you talk to people who have good sleep, you say, well, how do you fall asleep? They look at you like you're crazy. And they're like, what do you mean? I put my head down, I close my eyes, and I go to sleep. That's what I do. And if you talk to a bad sleeper, they're like, here's my 19-point plan, and you got to follow each step very carefully in order to go to sleep. And everyone's 19-point plan is independent, right? And so but it doesn't necessarily make it insomnia, right? Insomnia is really, you have to have this kind of daytime impairment. You have to have this anxiety, this stress about it. If it doesn't bother you, it's not necessarily good sleep, but it's not insomnia. So when you take a look at insomnia, the first line treatment is something called CBTI, which is cognitive behavioral therapy for insomnia. It's a very effective form of insomnia. There are various kinds of components. It's kind of like a toolbox. My clinical colleagues who do this, they're wonderful. It's kind of they basically figure out what's wrong with your sleep and then how to fix it. One of the interesting things about it is when you take a look at objectively how much sleep people are getting, or if you look at the EEG, the brainwave activity during sleep, there's actually remarkably little change in people who have insomnia and then when people no longer have insomnia. So you look at the same person and they no longer have insomnia. They will swear up and down they no longer have insomnia. They no longer have a problem with sleep. Their sleep looks the same. What's happened is that CBTI is really changing your mindset about sleep, is that you're no longer worried about it. Because frankly, the only thing worse than not getting a good night of sleep is not getting a good night of sleep and being anxious about it or being stressed about it. That makes it infinitely worse. So CBTI, it's great if you can do it. If this is something which you're amenable to, and not everybody is, this is a very effective treatment. Another thing that a lot of people use is melatonin. Have to say, when you look at the double-blind placebo-controlled trials, and this is a meta-analysis of a number of them, you actually see vanishingly little change in sleep. Around 6 minutes shorter sleep latency, and that really ranges anywhere from basically 0 to around 10 minutes. It's not very good. when you see people who take it as an open label study, so basically they know they're taking melatonin, then it actually works pretty well. It cuts down their sleep by a half hour, right? And that's because in those kinds of studies, people have removed the main barrier to getting a good night of sleep, which is their concern that they're not going to. They take this pill and they think, oh, now I'm going to sleep, and they can sleep fine. So in kind of many forms of insomnia, it is not a particularly good biological form, but it is actually a decent psychological one. Now, in ADHD, it may be more effective. And the reason is that one of the things that that melatonin is doing is that it is kind of reducing this alertness signal, the circadian alertness signal that's happening before normal bedtime. And so basically, if you're going to sleep too early, and this happens in some insomnia patients, is that they're basically going to sleep earlier than they should, then it's very difficult to fall asleep. If you take melatonin, this can help reduce that alertness signal and enable you to go to sleep. So in some individuals, it can be a helpful sleep aid. And so this is why, for example, when you're traveling, melatonin can be a helpful sleep aid because it is basically acting when you're not normally producing melatonin. So melatonin during the daytime can actually give you an extra 30 to 60 minutes of sleep. But at nighttime, again, it doesn't really give you that much. But if you're going to sleep at the wrong time, it can help. And so that's why if you have this erratic sleep schedule where your circadian clock doesn't really know what time it is and it's telling you to go to sleep at the wrong time, not when you want to go to sleep, taking melatonin on a regular basis could help. I have to say it has not been well studied in individuals with ADHD, but it is definitely a possibility that's out there. And then I know that lots of people use it. And so I did want to mention that. And I should also mention that it is the only hormone, and it is a hormone, that is not regulated by the FDA, which means that it does not go under the same scrutiny as every other medication that you would possibly take. And it's considered a nutraceutical, and because it's present in nanogram quantities in rice and bananas. And as such, it is not under the purview of the FDA. Despite the fact that if I was to use it in a clinical trial, I have to get special permission from the FDA, a different branch of the FDA, because there's insufficient safety data. So if you are using melatonin or planning on using it, I strongly suggest you find a manufacturer that has at least manufacturers under the UPS USB designation. And that usually means that they're self-selecting to follow these kind of good pharmaceutical guidelines. So, brief summary before we get to kind of Q&A. So, erratic or late schedules can lead to weaker circadian rhythms, which promote erratic sleep and more daytime fatigue. This can lead to compensatory behavioral changes and, in some cases, insomnia. Insomnia can be treated quite effectively by CBTI and, in some cases, melatonin. Reducing nighttime electronics can improve sleep regularity. Setting a regular wake time or use of a dawn simulator can help sleep regularity. And really, if you take away one thing, it's you got to pay attention to your sleep, just not too much. It's this careful balance. And that's really kind of the key here. Sleep is important, absolutely. It's important for maintaining a good circadian clock. It's important for good health. But again, the only thing worse than not getting a good night of sleep is not getting a good night's sleep and being up stressed about it. So with that, we've got Q&A.
Wonderful. Dr. Zeitzer, thank you so much for that really thorough, but also understandable presentation. Before we launch into the Q&A, I will quickly thank Inflow for sponsoring today's webinar, and I will circle back on our poll question that we asked at the outset of today's presentation. In it, we learned that 47% of today's participants say that their natural bedtime, when they would naturally fall asleep if work and school were not in the equation, would be after midnight. With nearly a quarter saying they would fall asleep around 1 or 2 a.m. And natural wake time, 43% said it would be after 9 a.m., which obviously impacts, life. So I just thought that was interesting for everyone who maybe feels they're alone in this journey. You are not alone. And I wanted to share just a few comments that came in, and then we'll get into the questions. This one was one of my favorites. The doctor deserves props for dropping the Tolstoy reference. It made my day. And the point is very clear, though, that lots of sleep challenges in the comments, and each one is different from the last. And another person wrote in to say, I wish there were 36 hours in a day, up for 24 and sleep for 12. And the last comment I'll pull out here, if left to my own devices, I would have 2 sleep periods each 24 hours. So kind of the flip of the last comment, rather than one long one, they would have 2 different sleep periods. So it is personal. Okay, so now on to our questions. We got quite a few very good ones. And I will start with someone who says that almost every day they start feeling sleepy around 7, but then they get a burst of energy at 9 p.m. and they're up until 2 or 3 o'clock in the morning. Are they missing their natural window? Is this common? Any advice for these people who feel that they're not able to take advantage of their natural sleepiness because it's just too early?
Yeah, so it definitely happens in adults. You see it more in kids, in young kids. It's this phenomenon called paradoxical hyperactivity, which is basically when you miss your sleep window, you get tired, and your brain's like, let me help you out. Let me help you out by like ramping up these random alerting signals, norepinephrine, dopamine. It's going to help you stay awake, but it's more of a kind of a hypomanic kind of state of alertness. So you're super active, you're super alert, and it's really hard then to turn everything off and relax and go to sleep. And so this is one of the things that can happen in some individuals when they miss their sleep window. And you see it in kids, like when kids get tired, then they get crazy. And then you have the misfortune of parents on planes giving kids for the first time antihistamines to help them sleep on an overnight flight, which works in many, but in some it causes this hyperactivity response, which is wonderful on an overnight flight to have kids who are hyperactive.
Yes, somebody just wrote in to say they call it missing the bus in their family. And yeah. I have been that parent. So I apologize to anyone who was on that flight with my son. It is not fun, as you said, for anyone. Okay. Another common question. Well, this ties into what you're saying about the amount of lux available to us outside versus in. Someone said that they feel they need less sleep in the summer and more sleep in the winter, and that also just rain and temperature fluctuations seem to affect their sleep. Is this all kind of part and parcel of the fact that greater exposure to outdoor light does induce no, actually, that doesn't make sense. Now that I say it out loud. No. Is there any research behind this and why you might need less sleep in the summer?
Sure. So do you need less sleep in the summer? There was just one study that just came out. Probably not that much less sleep in the summer. I have to say there is in the wintertime, you have a combination of, depending on kind of where you live, you have different kinds of night lengths and day lengths, depending on north-south, your position. I remember being in the Netherlands in January, and I was in my hotel room waiting for the sun to come up. And I didn't want to look at the clock because like my sleep was all messed up and like trying to figure it out. And it was 10 o'clock in the morning and it was still pitch black outside because, again, you've got much shorter days. So when you have these shorter days, your sleep can definitely become more fragmented. There's a circadian component to it, and there's also a behavioral one. And some of the behavioral one can be due to isolation. And you also have temperature components as well, which is that one of the key things that is happening during sleep is thermoregulatory, is that you're losing heat. And again, if it's very hot or very cold, this can be disruptive to to this kind of normal heat loss. So this is a long and ineloquent way of saying that it is quite possible to basically feel like you need more sleep. Biologically speaking, you probably don't need that much more sleep, but there definitely may be a greater amount of sleep that you feel, or you may feel more sleepy during the daytime.
Got it.
And that gets to the light. The light can help, stop that during the daytime.
Mm-hmm. Bundling up, getting outside on a day like today. Now, this is a common one. A number of women here are asking, is there any research tying hormonal changes to sleep and circadian rhythm changes, specifically estrogen loss in perimenopause and menopause? If you could speak to that, that would be wonderful.
Yeah, so it's a great question. So the big one is during the menopausal transition, there is a huge increase in women in sleep apnea. And so the loss of more on the progesterone end basically causes slight weakening of the throat muscle. So sleep apnea is basically this condition where you have pauses in your breathing. In someone where it's mild, it's happening, say, 5 to 10 times per hour. In someone in severe, it's happening 50 or 60 times an hour. And so basically, in a severe case, 50 to 60 times an hour, you stop breathing, you choke yourself awake, you take a gasping breath, and you go back to sleep. So you think of that happening every single minute. It is very disruptive. It is damaging to your brain. It is damaging to your heart. For women have very low rates premenopausal. Postmenopause, and in the perimenopause period, they now match what the rate in men. And so many times what happens is that women during this transition develop apnea. They don't recognize it as apnea because other stuff's going on. You've got work transitions, family transitions, you're becoming caregivers to older parents, your children are leaving the house, there's all sorts of stuff going on. And many times that I'm so tired during the day, you don't think of it as a sleep problem because you're like, I sleep 8 hours a night and I'm exhausted. And what's happening actually is that, well, you're in bed for 8 hours, but your sleep is incredibly disrupted. And so, again, many times they don't realize it because they've never had it. A common kind of signature of it is snoring, but not all snoring is apnea. Not all apnea has snoring, so it's not a perfect kind of a marker. But it's definitely something that is often ignored when people go to the doctors and they think well, is it a thyroid problem? Like, why do I have low energy all day? Thyroid problem. No, it's depression. No. By the time they get to sleep, it's already been too long and there's been a lot of damage. And so it's something which is definitely happening. When you look at hormonal changes over the course of the menstrual cycle, over the course of around 28 days, there are some changes in sleep. They're really not that robust. I mean, they're definitely like a couple of minutes here, a couple of minutes there, but it's not really very large changes. And so some of those changes aren't due to that. When you're looking at aging, and this is kind of independent then of these hormonal changes, there are also other changes, which is that your ability to block out signals that would disrupt sleep kind of go down. And again, so if your circadian clock isn't working well and you've got this, it becomes very hard to stay asleep. So for example, the garbage truck comes by at 4 o'clock, at 6 o'clock in the morning, and you wake up, and by the time you're fully awake, you don't realize that it was the garbage truck that woke you up. And it never used to, but now it does. Or sunlight coming in through your window can wake you up. Again, that can be a problem. So, the creaks in the house wake you up. They never used to. Why? Well, it's just your body doesn't do this. And the indigestion that you can sleep through when you're 25 years old and you're 65 years old definitely will keep you up. So there's all sorts of ways that the brain kind of doesn't work quite as well with sleep as you age. But in women specifically, the apnea risk is really a very clinically significant one.
That's really fascinating. I just recently have learned about how obstructive sleep apnea can look quite different in women, and how the research is just sort of catching up now. So that's an area to explore further, for sure, and something I think a lot of people overlook for good reason. A number of people wondering about the levers of diet and exercise. Are there things that we can do in terms of timing, foods in a diet, and or how strenuous exercise is during different times of the day to promote a more, standard, regular, healthy sleep schedule?
Yeah, so sleep research is messy, exercise research is messier, and when you combine them, it's a Jackson Pollock, right? It's just splatter. It's terrible. There's a lot of research out there. Some of it's good, some of it's not good. It's very difficult to interpret. There was a recent study that came out from colleagues at Monash using Whoop data. Whoop is one of the wearable devices, basically showing that you should go to sleep at least 2 hours after your exercise is completed. We don't really know about how regular it needs to be kind of effective for sleep, or what kind of intensity, can you do? We do know, so what we know is that, people who exercise more, it's easier for them to sleep than if you exercise less. Is it the anxiolytic? So is it the fact that, it reduces, stress? Is it something released from the muscles that is kind of activating it? Is it something to do with thermoregulatory changes when you exercise? We really don't know. And so this is the kind of thing where I do a lot of work in wearables, and I'm not a huge fan of the current wearables that are out there. First of all, they're not particularly accurate for sleep. But even if they are, at this point, most of them aren't doing very effective feedback. It says things like, you didn't sleep well. There are some, like I understand now, Garmin has a feature in it which will actually help you track your activity and how it impacts your sleep, which is great. And that's what really more of them need to do, is to do that. Because frankly, it doesn't matter how exercise impacts my sleep, it's how it impacts your sleep. And so it means that, because everyone's exercise is going to be slightly different, so if I play volleyball, which I play volleyball for my exercise, and hike and bike, that's how I get my exercise in. But if you lift weights, or you or play racquetball or tennis or whatever it is you do, it's going to be a little different. Your body is different from my body. Everything's going to be a little different. And so that's where these trackers eventually can actually start to help, is to really say, okay, well, when you have this degree of regularity, your sleep's improved. Or when you move your sleep timing around, your sleep's improved. So that, I have to say, it's a great question. We have terrible answers at this point, but I am optimistic for the future in terms of how wearables will actually help answer that question. With with eating, it's a very similar kind of thing. Too much animal work I've done. Animals don't eat; they get fed. But in humans, when we eat, again, having regularity is great. The one thing that is clear is that when you eat at the wrong time, so you're eating basically during what we call the biological night, which is when your circadian clock is telling you it's time to be sleeping, you do not process food as well. And so you're going to have increased risk of things like diabetes and metabolic disorder if you eat too much at night. There's a lot of anticipation about that. And so having kind of regular food timing is great. Different people, again, can have very different food timing. Like I typically don't eat breakfast, but I haven't done that for 30 years. So for 30 years, I haven't eaten breakfast. So, I have, my meal usually is, my last meal is usually at 6 p.m. at night. And then my next one is like at 11 a.m. the next day. That doesn't make me a good person. That's just how my body likes it. As long as you are regular about it, that's really the key thing. So being regular about it and avoiding it at night. Macronutrient really is not very well understood in this context.
That's very helpful. It poses the question whether there's been any research on like an intermittent fasting diet and its impact on sleep.
Yeah, so people have looked at both intermittent fasting and also so intermittent fasting, where basically you have fasts periodically throughout the month, as well as what is called time-restricted eating, where you only eat during certain times of the day. Both of these, especially the intermittent fasting, seems to have fairly robust effects on physiology. It doesn't have huge effects on sleep, but it does. At least the intermittent fasting seems to have more of effects on longevity, at least in rodent models at this point. But again, sometimes having the time-restricted eating can be very helpful, especially if not on the positive end, but on the getting rid of a negative thing, which is that sometimes basically people eat and they've got low motility through their gut, and then they'll have indigestion or heartburn when they try to go to sleep, which can become problematic and difficult for them to fall asleep. And so kind of having an earlier timing is one thing that's been shown to be helpful there.
Mm-hmm. I think one of our experts in another presentation said something that stuck with me: nobody's eating broccoli at 9 or 10 o'clock at night. So there's that aspect of it. Whatever you're eating is probably not helping you fall asleep.
Well, it's, one of the things that happens is that you've got, is that when you're up, when you're not supposed to be up, is that you have a release of something called thyrotropin, thyroid stimulating hormone, which basically is normally suppressed during sleep, but almost doubles during sleep deprivation, or when you're awake at night. And this triggers signals to increase energy intake. And you basically overestimate how much energy you need, because your body's trying to help you out. Like, oh, you're up at this weird time. There's got to be something chasing you. So let's get you a lot of glucose and fat right now. And so, so you crave things that are not going to be necessarily good for you long term, and you're grossly overestimating the number of calories. Your body is grossly overestimating the number of calories that you actually need at that point.
That's fascinating.
Circadian.
I wanted to touch briefly. You covered melatonin in detail, and a number of people have also asked about magnesium and if there is any research linking magnesium supplementation to improve sleep outcomes.
It's been equivocal. So there have been a number of supplements that have been studied, but not particularly well. And so it's unclear if there is a robust effect of magnesium. One of the problems in many of the supplement kinds of studies is that typically supplements have a better chance of working if you're in deficit. And most people aren't in deficit of most of these things. And so that's number one. And number two is, many times, even if there is a positive impact of something, it's usually not, it's not like, oh, it's going to increase your sleep by an hour, right? It doesn't increase it by a few minutes. And so you need to look at people whose sleep is very good, and then this gets it better. And so many times in these studies, it kind of conflates these different kinds of populations, and it becomes very difficult to see. So again, I'm not saying that there is an effect. I'm just saying it's not a very well-established effect.
Okay, wonderful. Well, sadly, we have run out of time today. This was just a really eye-opening and useful presentation. Dr. Zeitzer, thank you so much for joining us today and for contributing to the ADDitude community.
Well, thank you for having me. I hope people learn something and come away a little less worried about their sleep.
Yes. And thanks to everybody who joined us today. If you have ideas for other webinars you would like ADDitude to hold, please share them in the comment box, or know that you can email us anytime at customerservice@ADDitudemag.com. And if you're looking for the event resources and the replay for today's event, you can search ADDitudemag.com, search for podcast 595. The slides and recording will be available early tomorrow. If you're listening in replay mode, just click on the episode description and know that our full library of webinars is available as a podcast. It is called the ADHD Experts Podcast, and it's available on most streaming platforms. We hope to see you for another free ADDitude webinar next week. The topic will be family dynamics and ADHD with Dr. Tamara Rosier, and that is on February 17th. And then on the 24th, medical gaslighting, when willful ignorance causes doctors to dismiss your ADHD concerns. Make sure you don't miss any future ADDitude webinars by signing up to receive our free email newsletters at additudemag.com/newsletters. All right. Well, thank you again, Dr. Zeitzer, and thank you, everyone. We hope you have a wonderful day and a restful night.